Hey, hi everyone, welcome back to Code Eaters. And this time we have come up with a video which consists of a top SQL interview questions, and this is like top 25 SQL interview questions. So here I have segregated a set of questions into the 5 sections. So I will explain each. So it will be like basic SQL query and concept. It will consist of 5 questions. Intermediate SQL query and design, then advanced SQL query and optimization, database theory and transactions, scenario based and practicals. So these are the 5 different types which generally asked in your interview. And I want you to like understand the question, just not like, okay, this is a SQL question. No, what kind of SQL question is it? Okay, what are the levels of it is. So like it may help you in analyzing the question and also how to answer these questions. Now, instead of just solving a problem, we will do analysis on the problem. What kind of problem it is, what exactly we are learning from this problem, and what interviewer is looking into like once he or she asks this problem to us. So we will see all these scenarios and all these conditions. So first I will go with the first section, which is basic SQL queries and concepts. So this is your first question. I'll read out the question for you, which is write a query to find the high salary employees. And the question statement is write a SQL query to select all the employees for an from an employees table with a salary greater than 60,000 ordered by salary descending. Okay. Now, what kind of question is this? So it is a coding type question. Coding in the sense like you have to write it the SQL code. So it's kind of a practical. Now, what it tests basically, it tests like how you write your query. Okay, and also in the query, this particular question will give you clarity on the select part, on the where clause, on the order by, and the query structures. So let's solve this problem. What I have done for this particular problem is like I have like in my PostgreSQL database, I have created a table called employees, and I will do all the SQL writing and all this on this particular table only. You can also like do the same, but yeah, just looking the questions and like how I solve, you can like it will be enough and sufficient. You don't need to like write it, but yeah, for uh, for your understanding purpose, I highly recommend you to like you can take a screenshot of the screen, or write it in your notebook. I usually write on my notebook, so yeah, it helps me. So this is our PG admin, okay, Postgres admin, and let's write the first. Let's see what are the data present in our SQL table, employee SQL table, which is select, then your star from, and your this is the employee. Okay, let's execute the code. So we can see that what are the columns we have. We have employee ID, which is your primary key, first name, last name, email, phone number, hire date, job ID, salary, manager, department ID. These are the stuff we have. Now, what is the question? The question was to write a SQL query to find all the employees whose salary is greater than 60,000. Cool. So what we will do is first select star. So I'm going to select everything from this where. Now you will understand how the where condition works. So although in the coming videos there are some detailed discussion on the where clause, so yeah, I will take care the complete understanding there. In short, the where basically works row wise. Okay, it selects us every single row and then it does the computation or the condition which you provided. So here you will write the condition, and I will say where salary is greater than 60,000. Okay, let's execute this. So I can see we receive 4 rows. Okay, and these are those rows where the salary is greater than 60,000. So let's discuss the second problem, which is what is the difference between where and having clause. It's a theoretical based question, and it will build your filtering mechanism and query execution order. So the major difference between where and having clause is that where filters individual rows before aggregation. So in short, whenever you write some condition with the where clause, it will go row by row, whereas the having clause will do the filtering post group by. So once you have created a group, only then it will do a filtering on top of that group. and the where will do the initial this filtering. Now you can't apply a aggregation function on the where clause, okay, but you can apply a aggregation function with the having clause. And the main key difference is like the query execution. What I mean with query execution is that, so this is where applies to rows and having applies to groups. And the execution of order is that first for will be from will be executed, and then the where will be executed, then group by will be executed, and then the having clause will be executed. Okay. So whenever you require to filter a data, okay, based on their columns, always go with where clause. Okay. And when you require to filter a data, but it required an aggregation, in that case, go with having clause. Now the next question, the third question is write a query to count unique customers. Okay. So what you will learn from here is basically, as you know, count is a aggregated function. Okay. Count is an aggregated function. Distinct helps you to find the distinct or the unique values, and these are the concepts you will learn from this particular question. So we have to write a SQL query to count the number of unique customers in an order table. So back to our PG admin, and here we will write the SQL code for finding the unique customer into our order table. Okay. So first we'll see what are the data we have. Select start from order table. Okay. Execute this one, and let's find like what are the like customers we have. So in the customer name, you can see that we have Alice, Bob, Alice, Charlie, David, Alice, Eve, Bob, Frank, and Charlie. And what is the question? Question is asking for the distinct customer name. So what we'll do, customer name. So we'll find the distinct. We'll see distinct customer name. Okay, done. Now the question, the second part of the question is like you have to count them. Okay, so we will use the aggregation function count with the distinct. Okay, so we'll write count, and we got the answer, which is 6. Now the next question we have is the fourth one, which is what are primary keys and foreign keys. As this is a theoretical questions, and we will discuss like what are primary keys and what are foreign keys and their roles, and with some examples also. Here this is very important question. I'll create a separate video on this also. Why it is very important? Because it helps you while designing a schema or a data model. It's help you in data modeling also. So I'll quickly jump to the example, and let's see what exactly the example says. If you want, you can take a screenshot or put in your notepad or something. So here is the example. Now you can see we have two tables. One is the department information and another is an employee info. Okay. So you can see that each department have like 101 belongs to IT. Okay. 102 belongs to electronics, 103 belongs to admin, and 104 belongs to accounts. Now in the employee info, you have like these details. Every employee ID you have, okay, and each employee is belonging to a department ID. Okay. Definitely, if you are an employee into an organization, you will be assigned to one of the department. So this is the relation. Okay, so we related these two tables within a department ID. First observation, department key is a primary key into department information. Okay, and in employee information, employee ID is your primary key. Okay, so these two table, this is a primary key and this is a primary key. Now once you do a what you can say, once you try to find the information of an employee with respect to department or some different table, you need to provide that bridge. Okay, so this foreign key is a bridge which connects this table to this table. Okay, so a foreign key is nothing, is a primary key to another table, which is the bridge. Okay, so let's suppose if you want to go from employee to department, you need a path, right? This foreign key is the path. Okay, this foreign key. So you need to have the address of that place basically, right? So department ID, how can you identify a unique department with this department ID? So you need to find that department ID feature into your employee table so that you can identify employee belongs to which department. Okay, I hope you have understood till now. Okay, and I'll create a separate video for this particular topic. But yeah, let's move on to the next question for now. The question is, write a query to find the null values. Okay, this is very common question, or like it is one of a part comes into some questions. So you have to find this null and non-null value. Okay, null means it have no value. Okay, null is not a value. Remember, okay, don't say that it's not zero. Zero is a value. Null is nothing, and that is called null and is null. I mean null and not nulls. So let's go to our this PG admin. So back to our PG admin, and let's see what are the nulls we have. So I'll think I have some null values in my employee. Let's see. Start from employee. Okay, do we have any null values? Yeah, we have one null value here. Okay, so let's see. So in the data, what we'll do is say provide me null ID. Okay, so what you can write is select start from employee where manager ID. What is this? It's written manager ID. Is it manager ID? It is. Manager ID is null. Okay, so you're saying give me the record where manager ID is null, and we have one record. Now give me the records where the manager ID is not null. Is not null. We'll receive these values. Okay, where the manager ID is not null. Okay, so we have completed the first section of this video. Okay, now we'll move to the next section. Here the questions will be a little like intermediate level. Okay, and this is the first question, which is like find the employees with above average salary. Okay, now focus on this keyword, average salary. Okay, so this is the question and this is a problem statement. Okay, write a SQL query to find employees from an employees table whose salary is greater than the overall average salary. Here you will learn about there are multiple ways to solve this problem with a CT and all those stuffs, but let's try to solve this problem with subquery. I'll give you a very basic understanding of subquery. Subquery is a query, a separate query, a completely separate query having all of these like select. I'll give you a little understanding on the subquery. What exactly is subquery? Subquery is a complete query executing inside another query. And aggregated function we will use average. I highly want you to like go to Google and search for the aggregated functions and learn about them. I'll try to cover as much as possible, but yeah, there may be some left. Okay, I'm not very sure on that one, but I'll try to cover as much as possible in our upcoming videos. So let's write this question, or like let's solve this question. Back to my back to our this one console. So first thing, let's see complete data. Select star. So this is the complete data. Now what you saying that I want employ all the employees whose salary is greater than its average. Okay, so first find the average salary. AVG average salary. So we found that okay, this is the average salary we have 56,493.33, which is like close to 56,494 approx. Okay, now my task is to find which is great, whatever is greater than this. Okay, whatever is greater than this, right? So let me write a query. Select star, or the question is select m select star from employee where, okay. So this is your subquery. Okay, we have read this. Where salary, sorry, I missed. Okay, so this is what you do. This is your subquery. This section is your subquery. Okay, and this is the main query. Okay, so this is the subquery and this is the main query. Let's execute this. So if you remember, what were our average? Our average was something close to 54,000, and these all values are greater than this. So this is how you come up with uh, this question. This is how we solve the question. There are multiple ways to solve this particular question. Okay, we can try different ways also. We can use with the CTE. These are the things I will discuss in the later videos. Now we have another question. Obviously, it's a theoretical question now, which is group by and order by. Okay, let's understand this one. What exactly group by means and what exactly the order by means. So as you know, this is another theoretical question. So we'll understand the grouping and the sorting. So order by is nothing, just a sorting. Okay, nothing much. And group by is what? Group by is grouping. Okay, so case one. Let's suppose in your classroom, first I will say, uh, students, please align in a single line with ascending or descending order. Okay, so that is ordering. Okay, I'm ordering them to stand in a, I mean this I'm shorting them with height. Okay, ascending or descending, or I can short them with the uh their roll numbers. I can short them with the marks. So these are what I can do. Okay, this is called order by, the sorting part. Now what is group by? If I say you in your class, class create groups like boys or girls. There can be one group, another group like group yourself with respect to who got A, what are the number of people who got B, C, and D. Okay, so that is grouping. Okay, this is the basic understanding I provided you. Now how this helps in our this SQL part. So I'll go with the SQL. I'll go with the PG admin and I'll write some query too. So first understand the group by. Sorry, first let's understand the order by. So this is the ordering first. Okay, I mean this is the complete data. Let's apply a order on top of the salary. So I want to know what are the highest salary. So I'll do an order by with respect to salary, and it should be decreasing. So 63,000 is the highest and 50,000 the lowest. You can do the alter also, like just to remove the decreasing, you can write ASC, or you can also don't need to write ASC. By default, if you don't provide ascending or descending, it will go for ascending. So if we come here, we can see, okay, yeah, it's from smaller to larger. Okay, now you have understood this group by part. Sorry, the order by part. Let's understand the group by part. First, let's see the data. What you can see is like job ID. You can see like, so I want to segregate dev, QA, and HR. Okay, so what I'll do, I'll write a group by. Okay, group by on what? On uh, what was this? Job ID, right? Job ID, job ID. Execute this. Okay, there was some problem. Let's see. Okay, yeah. So whenever you write this in a group by, the select part need to be there. Okay, so whatever you are selecting in your group by need to be there. Okay, and then you always use a aggregation with the group by. Okay, so let me use a count. Okay, how many peoples are in HR or in dev or in QA? So I'll use count. Okay, count star. So I'm grouping with job ID, and then I'm seeing in each group how many peoples are there, or what are the number of peoples. What is the syntax error at near job ID? Line 1. Let's see. Group by job ID. Select job ID. Select start from employees. Group by this. Why? Okay. If I want, so these are the groups. Okay. I want to understand why it failed. It should provide me the count using aggregation function. Count. Okay. Let me do an employee ID. Okay. So we found this one. Okay. Like what are the number of employees belonging to QA, Dev, and HR? So four. There are four QAs. There are seven Dev, and there are four HR. So this is how you can use a group by. Okay. You can also like find another aggregation function is like average. Okay. Or you can look at sum of the salaries. So salary. So these are the sum of the salaries. So what basically we did is like we grouped them into their respective job IDs, and then we did a sum on top of each group. Okay. And if you want to do an order by here, you also can do. Okay. Inside a group, so you can like I add order by order by what? Let's suppose I want to order by its sum. Okay. So sum salary in descending. So I'll show you first what we have first. So you can see that 21,000, or like is it 21,000? Okay, it's something close to 2 lakhs. Okay, 2 lakh, 4 lakh, 2 lakh. Okay. So I want to short this one now. So I'll use the order by here. So now it's shorted from descending. If you remove this part, so we'll do an with ascending. Okay. If you don't want to short within this, you can want to short it with job ID, you can do with that also, job ID. And as job ID is a string value, so it will short it with the this alphabetic order. Okay, like D, H, and Q. Okay, so this is how your group by and order by works. So in short, order by will order do the shorting and group by will do the grouping, in short. Okay. Let's move to another problem. So let's solve the eighth problem, which is retrieve recent records. Question says that write a SQL query to select the 10 most recent orders from an orders table, including order ID and order date, sorted by date descending. Okay. This is the coding type question. Basically, you have to write some SQL code, and this will check your limits, order by, and date handling part. Also, it's an intermediate level, and I have shown how to write this code. Okay. So let's go to our PG admin and solve this problem. So as you can see, we have orders table. Let's execute this. And what we can see is we have order ID and order date. Now our task is to find the top 10, or you can say the top recent orders with respect to time. Okay. So you know that how can we get the recent part? This one is like with the help of ordering. If you sort the data set with respect to time, okay, in descending order, then you will receive a date from the latest to the oldest. Okay, or newest to the oldest. So let's write order by we have something called date. So if you see order date, so if you go with the order date, and it's descending, so we have to write the descending part. Let's execute this one. Okay, there is some problem. Order date. I think we don't have something called order date. How? Wait. So if I execute this, okay, it's order date without an underscore. So order date. So what I'll do is order by order date. Let's execute this one. So this is like with the latest. Okay. uh, so the very first one is your 2023. Okay, it's ascending, is it? Okay, we need descending, so DESC, descending. Execute this. So you can see this is the latest one, and now you have to select the top 10. So just use the limit part, seeing that limit is equals to 10, and you are done. So this is the output we receive. Okay, now the next problem is ninth problem, which is use of foreign keys. So this is a similar discussion we had in our previous problem, which was primary key versus foreign key. In that, it will give you the better idea. So I won't repeat the same thing. So I want you to please refer to that solution in the same video. Moving on. So now this is our 10th problem, which is write a SQL query to count the number of orders per month in 2024 for an orders table. And it's a coding type, and basically we'll understand the how date function works, group by aggregation part. Okay, so this is sample code which is in front of your screen, and this is the similar how we'll try to solve this problem also. So let's go to our this Postgres. Okay, so first thing first, we have something called order ID. Okay, order ID, order ID, and this order this. Okay, let's execute this one. Now I want, and this is, and the problem is asking for month wise. So we have to extract the month part. So in that case, if I do this, okay, and month, okay, so let's execute this. Okay, there is nothing, something called month is not here. We can't extract the month from the date here. Now in Postgres, to extract the month, we have something called extract month. Okay, and like same we have for year also, and date. So I'll use this one. If you are in different, like if you are in MySQL, then just month will work. Okay, month and the date column. But as I'm using Postgres SQL, so this extract will work. Okay. So let me execute this one now. So now you can see that I have order ID, order date and month. Okay. And I want only for 2024. So I'll write this one where extract, I'll extract, I think I'll use this one, extract year from order date, and which should be equals to your, I think it should be equals to 54. Let's execute this. Yep. So we have all 2024. Now we have to club all the month. Okay. And now the part, so we did the filtering. Now we have to group by with the month. Okay. Group by month. Okay. And then we have to come up with your date. Okay. So count order ID. Okay. And order ID I have. So let me execute this one and see what is the problem. Okay, so it's saying that order must appear in the group by. It should appear in the group by. Okay, yes. So do I require the date part? No, I don't require the date part. So I don't require this to. Yes. So for the month first, which is January, we have only one entry. For the month of February, we have one entry. For the month of March, we have two entries. For the month of April, we have two entries. And for the month of May, we have three. For the month of June, we have two. So this is how the group by and rest of the part works. Coming to the next problem. So now we are moving to our third section, okay, which is, and the first question is optimize a query with indexes. Question is like explain how indexes improve query of performance and when you would avoid using them. So first thing first, I will create a separate video on this particular topic. It will be a very detailed video, but for the now, I think we'll go with whatever we have right now. That is enough to like crack this one interview. I think because in interview we don't have much time, so I'll think we just need to give a crisp answer and yeah. But still, I think this topic need a proper dedicated video, so I will create a proper dedicated video on this one. Okay. Now, as you know, this is a theoretical based question which basically understands or like we basically show your understanding with respect to indexes, okay, and also optimization. So let's read the problem and go through the solution. So the solution is indexes speeds up the select query by allowing faster data retrieval, but slow down the insert and update due to index maintenance. Avoid over indexing or write heavy load tables. Okay, so let me explain you this how exactly this works. So basically, what is index? So if you understand, you have a book, okay. In your book, the first page is the index pages, okay. And here you have written, okay, this chapter belongs to chapter 1 belongs to page 1 to page 8. Chapter 2 belongs to page 10 to page 20. Okay, same forward, okay. Now, if you want to go to chapter second, so you will go to the index and you will search. Okay, I just need to take care of chapter 10 to page 10 to page 20, and I will be require and I will get all the details regarding chapter 2. Okay, this is the index you receive. So it is easy while reading out. If you want to go to chapter 10, just go to index page and see which page consists content from chapter 10, and you will land there. Same happens here. So if I say all details related to uh, Apple is stored in row number 30 to row number 20, 40. All details for Deloitte consist from row number 10 to row number 13. Okay, so you don't need to what you do say you don't need to filter or search the complete table. You just go to that particular index and your searching will be optimized. Okay, this is the case when you try to read the data. But let's suppose if you want to write the data, so what you have to do, you have to do a re-indexing basically. Okay, let's suppose you want to insert the data belongs to Deloitte. So you know that the data, the index is from row number 10 to row number 13. So you need to provide the index 14 to the Deloitte and update that index 10 to index 14. Now index 10 to index 14 belongs to Deloitte, so it will also like update the rest of the indexes. Okay, it totally depends upon which database you are using. As in BigQuery, we don't have a concept of indexing, but majority of the places we have the concept of indexes. That's why it said if you have a heavy read operation, indexing is the best thing. But if you have a write or update, then indexing will not be a very good thing to be like implemented, because every time when you do an insert, you have to take care of indexes separately. Okay, so I hope you have understood a little bit for the optimization query indexes. Okay, and how optimization. So whenever you try to read a table, it is highly optimized, because instead of, let's suppose you have millions of rows, but you know that only first 100 rows consist the data belongs to Apple, then you won't search the rest of millions record. You will just focus on the first 100 records. This is how indexing helps in the reading part. Okay, I hope you have understood till now, and I'll highly recommend you to please jot the sample answer, okay, what I have written on the screen, and you can use it in your interviews while providing the answers. And yeah, once I come up with the detailed video on the indexing, it will help you more. So, moving to the next problem. Okay, now this problem is called rank employees by salary within department. Now basically this is a place where you will understand the window function. Okay, now this question, window function, is an advanced topic. Okay, and this helps intermediate or advanced level data engineers or data analysts or anyone who is into the SQL domain, okay, to write very optimized or you can say to write very clean SQL codes. Now, in the type, it's coding, and this will teach you window function, the rank, partition by. I have discussed this one in one of my videos. I will provide the link for that one on the Windows function. Meanwhile, let's go through the question. Okay, so your task is right now to find the or to provide rank to the employees within each department based on their salary. Okay, using a window function. So I'll go to my this table, employees table. So select star from employees. Okay, this is the employee table we have, and for each department you want. So let's see how many tables we have for each department. So let's first discuss this one. So you can see Alice belongs to HR, Alice again belongs to HR, and Alice again belongs to HR. Okay, I think we'll have to select a different table. Okay, yeah. So yeah, this is the employee table I'm talking about. Now what you can see here is we have different job IDs, okay, or you can see the department ID. Let's go with the department IDs. So 101, 101, 101, 101. Like there are multiple 101s and 102s, okay. So there are basically two departments here in this complete table, and you have to rank each employee with their salary in ascending or descending order. So in that case, what we require, we will require a rank. So to provide a rank, you have something called rank in the window functions, and this comes with an over clause. So over clause and then partition by what partition you want to take. It should be on department wise, so department ID will be the partition column. So department ID, and then you have to do an order by what you have to do an order by salary in descending order and provide some alias to this rank, and let's execute the code for now and see. So it's saying partition by department, so partition, okay, the spelling is wrong, partition by. So now you can see that, okay, yeah, now you can see that we have 100, 101, this is 101, this all belongs to 101, okay, and here the ranks are there. This is the first rank, belongs to this one, okay, 63,000, then 62,000, 62,500, 62,000, 61,000, 60,000, 59, moving forward. And then you have a different department, okay, and you can see here that this department have like ranked, okay, so all HR comes here, okay, and this all belongs to 102 department, and this is how it's sorted with respect to salary wise in descending order. So I hope you have understood till now. Moving to the next question. So let's discuss 13th problem. Problem statement says that write a SQL query to pivot sales data from sales table to show total sales by product for each quarter of 2024. So let's break down each problem. First thing first, we will understand what this question is like helping us. So with while solving this problem, you will understand the concept of pivot. Okay, it's an advanced topic first of all, and it helps into analyzing a lot. So here what we basically deals is you have a huge data set, and now though having multiple rows, so to summarize, this is pivoting you also use for summarizing. So I'll tell you what exactly we mean. So you may have multiple rows, okay, and the main concept of this is to convert these rows into columns so that it gives you a summary, okay. So let's understand with data first of all. We have to understand the sales table, okay? And then from this sales table, what we have to do, we have to do for each product and for each quarter, okay? For each product, for each quarter in 2024, we have to come up with the total number of sales, okay? So let's understand the problem with table first of all, and whatever you are seeing is the solution, but I'll first discuss this one and then we'll come up with the solution. So first let's execute the sales table. So you can see that you have multiple rows here. Let's understand the each column. So first is the sales ID, then you have a product ID and the amount, and then the sales date. So first what you have to do is you have to first of all filter out the data for 2024. As per the question, it is saying that you need to pivot a table for 2024 quarter wise. Okay, so let's first understand what quarter means. So in a year there are 4 quarters. One quarter consists of 3 months like January, February, March, and moving forward 4 times. So let's see understand the quarter part. So we'll extract the quarter part from the sales data. So I have already written the query. So the query says that extract. So this is a clause in SQL Postgres which you can use. Extract. So you will extract the quarter from sales date. Okay, quarter is already an understood terminology in date. So extract quarter from sales date. So let's execute this one. So now what you can understand is this row, the first one, where the sales ID is 2 and the product ID is 1. For this one, sale date is 2024, 20th of February, which comes under first quarter. So likewise, this comes under first quarter. Okay, this whole record comes under first quarter. Again, this record comes under second quarter. Then this record comes under third quarter, and this comes under fourth quarter. So what you have to understand is, or what you have to come up with, you have to come up with a table where you will have a sum up of each quarter, like quarter 1, 2, 3. Okay, so this, instead of these rows, these will become your columns. Okay, so right now you can see that there is a quarter and having these rows, multiple rows. So, but now you will have a column for that one. Okay. So this is the original table we have. Okay. And we have the sales date. So from this sales date, we will extract the quarter part. Okay. We will extract the quarter part. So, and what we have to do, we have to come up with a table for each quarter. Okay, quarter 1, quarter 2, quarter 3, and same quarter 4. So this section, so first what we'll do, we will extract the quarter part, and then we will see this data set comes under quarter 1, this comes under quarter 2. Okay, from 6 to 8 comes under quarter 2, from 1 to 5 comes under quarter 1, from 9 to or 8 to 10 comes under quarter 3, and the rest 12 to 11, no, 12 to 14 will comes under quarter 4. Okay, so now in this what you have to do for each product, okay, let's suppose for each, here in quarter 1 how many ones you have, only you have one. Okay, so no, okay, this is the product one. So in quarter 1 you have two ones, you have two twos, and one three. So you will have three entries. We will sum this and this and this. So I hope you have understood, but I'll go back to the question and then again come back here. So I'll read again the question. You are saying you have to pivot the table. Okay, pivot the sales data from a sales table to show total sales of a product. Now you may have multiple product. Okay, so let's go one by one. You have to read 2024 data. Okay, cool. Now you have to read it by each quarter. So quarter 1, quarter 2, quarter 3, and quarter 4. So these are the 4 quarters. Now in this you have to come up with each product. So now this is your columns, this becomes your column. Now for each product, okay, product 1, what is the total sales happen in quarter one, what are the total sales happen in quarter two, what are the total sales happen in quarter three, and what are the total sales happen in quarter four. Now come to product two. What amount of sales happened in quarter one, what amount of sales happened in quarter two, quarter three, quarter four. Same for third product. So this is how we will populate our table. So at the end, this is how it will look like. For quarter one, if you see the data, if you understand the data, see, sales, quarter one sales is 250 for one. Let's understand. This is the quarter one. Okay. So this is quarter one, and what are the one? So this is your one. What is the value? 150 plus 100 is 250. So for quarter one, quarter one, you have 250 summation of this. For two, product two, in quarter one, you will have 75 plus 50, which is equals to like 125, which is 125. For third, it's one entry only in quarter one, so 80. 80 it is. Now for quarter two, so it will go down. See, for quarter, these are the quarter twos. So for quarter two, you have one entry for 1, 2, and 3. So same will be printed. So 200 for one product, 150 and 60. 200, 60, and for two it's for two it's okay 125, which is here 125. For quarter three, you have 1, 2, and 3, which is 300, 130. Same will print because we don't sum it. The only summation happened is here. So I hope you have understood till here what exactly we did is we took one row and we filter. So how we populated this? We are going row by row in table, and what we are doing, row to column. Okay, so we are picking one row. We are seeing which this row belongs to which quarter as per the quarter. Okay, this belongs to quarter one. Okay, in quarter one, what is the total sum? So we'll do a sum on all the product which belongs to quarter one for product one. So product one, okay, it's 100 and 150. Okay, so this will gives you 250. So this is how we like come up with the solution. Now let's understand the code. So this is what exactly I did here is for each product, we'll do a sum. If you see, this is the sum we are doing. Okay, sum of what? Sum of amount, right? So what we are doing is first we are extracting, we are checking that this belongs to which quarter. If this belongs to 1, then go for an amount, else 0. Okay. So now let's write the code. So this is our code. So first what we did is, let's ignore this one first of all. Okay. So first we selected the product ID. Okay. And we filter out for 2024. Now 2024 we are done. Now we have to select which quarter which product belongs to. So for each product ID, okay, so what I'll do is sum, or let's not write, let's write the case statement. Okay, case when your extract this part basically. Okay, so start from sales date. So when extract from sales date, so if this belongs to 1, which means it's from quarter 1. Okay, case when extract this belongs to 1, then take the amount, right? If we go with the output, this is the amount we require, right? So take the amount. Let's suppose if this product doesn't belongs to 1, then in the else part, so it will go in the else part, else 0. Okay, now we will do the sum on top of this sum, and then we'll mark it as q1 sales. We'll do the same for 4 times. Okay, and we'll update this one. So if this belongs to 2, if this belongs to 3, if this belongs to 4, then this column 2, column 3, and column 4. Okay, let's execute the code. Okay, what's the problem? Let's see the query. Sum as else 0. Okay, we have to go with an AND. Let's execute this one. What is the problem, brother? Some case. Okay, I missed the comma here. I hope it's about the comma only. Yes. So we executed this one, and this is how it is solved. So let's solve question number 14, which is explain query execution plan. So this is a theoretical question and the level is advanced. Here you will understand the query optimization, what are the places where you have to look, and how you can understand how your query is getting executed on top of a database. So the question is, what is query execution plan and how can it help optimize SQL queries? The first thing, what is a query execution plan? Basically, whenever you write a SQL query, you write a commands. Those commands are getting operated or getting executed on top of our database, a table or a view. Now, the SQL optimizer or the database creates those plans. So I have to, so you have written select start from table. So if you know how SQL query executes, so first it will go, it will fetch the table and then it will select the rows. Okay. If you have provided a star, then it will select all the rows, but if you have provided the column, it will select the column. So this the now the solution. So the answer is, so let me first explain you what. So a query execution plan shows how the database executes query. Example, scan and join. Use explain. So query execution plan shows how the database executes a query. Example, scans, join. Using explain, you can identify bottlenecks like full table scan and optimize with indexes or query rewriting. So I'll go with the example. So this is one example. We have already seen this one. Okay. Here we are trying to extract data from the sales and filtering or like extracting this part. Okay. So I'm using Postgres. So here explain analyze works. Okay. Even explain works, but this explain analyze give you a detailed analysis on the query. So if I write this one, if I execute, so this is the output I will receive. Now you can go one by one what exactly happened. So let's first copy this one. So when we did the analysis, we come up with these solutions. Okay. So as you are doing a order by, okay, that's why it applied in a short. Then the short is like, and this is the cost utilized. In it's saying that in this time you can execute this much rows, okay, 1450 rows, okay, but the actual rows was 14 only, okay, and the time taken is this one, actual time and actual row, as we have 14 rows only. Now you extra, so inside the sort what exactly happened, you did a sort on top of a key which is your quarter and your product ID. Okay, so first with the quarter and then with the product ID. Then this utilized a quick sort, which is so quick sort is the highly optimized sort here, okay, and which take 25 kb of memory. Now then you did a sequence scan on sales. So sequence scan on sales. Here again, it's this is in a standard one, okay, for this amount of time, and here it's also saying that the actual row you scanned is 14 only, okay, and this much time it took. So, and this is your planning time and this is your execution time. Planning time basically the amount of time your engine takes to plan a query. So let's suppose you write a query, so it has to come up with a plan what to execute first. Okay, so this is the planning time and the execution time. What is the after the planning is done, you made, okay, this is the plan, how much time it is taking to execute it. Okay, like filtering from the data, the actual work. This is the theoretical blueprint and there is the actual work, filtering from the databases. Let's solve question number 15. Find consecutive login days. The nature of this question is practical, or you have to write the query. The level is advanced. It will test your advanced logic and lead lag, which comes under window function. Let's go through the question. Write a SQL query to find users who logged in for at least 3 consecutive days in a login table with columns user ID and login date. So it's saying that you have a table logins which will have 2 columns, user ID and login date, which are these, and you have to come up with the user ID. Let's suppose, what are the user ID who logged in for consecutive 3 days. So let's go with user ID 1. Let's suppose user ID 1 Ram. So Ram logged in on 1st of December 2024. Then again he logged in on 2nd of December 2024. Then again he logged in on the 3rd of December. But on 4th he didn't logged in. On 5th again he logged in, and then 6th. So if you understand the meaning of consecutive, so 1, 2 and 3 are consecutive, 5 and 6 are consecutive. Okay, but he missed the 4, so 3 and 5 are not consecutive. Okay, now as per the question, it says that you have to come up with 3 consecutive days. So here Ram logged in for 1, 2 and 3. That's why 1, 2 and 3 is consecutive. So Ram is consecutive for at least 3 days. That's why he will come under the filter condition. But this date will not come, 3, 4, 5. Let's see for user ID 2. User ID 2 was available on 2nd, then 3rd and 4th. So user ID 2 is also present. But from 4th he was not available till 10th. So this is one gap. So it's not consecutive here. User ID 3 was available on 1st, then absent on 2nd, present on 3, 4, 5. So 3, 4, 5 is 3 days consecutive here you found. So we are dealing with the least, at least 3 days. So this will satisfy our condition. Now user ID 4, 4, 5, 6. User ID 5 will not come because user ID 5 logged in on 10th and 11th only. So it's 2 consecutive, not 3 consecutive. I hope you have understood the question till now. Let's try to write the query. So I will use a window function here, which is lead or lag. What basically lead says that lead is like the next and lag is previous. So if you come to the data, for example, what is the lead for this row, this column? Okay, third row, which is belongs to user ID 1, and user ID 1 logged in on 3rd of December. So lead to this date is 5th. Okay, and lag to this date is 2. Okay, lag is 1 before and lead is after. So what is lead, sorry, what is lag on first? Null, because there is no date prior to 1st of December. That's why it will be null. And what will be the lead for 11th, 11th of December? There is no next date. That's why it will be null. Okay. So what we are trying to do is we are trying to find the next days. So first, let's write this one. I'll go with the lead. Okay, I'll try to see the next day. So lead on top of what? Login date. Then I'll use an over clause, partition by user ID and order by what will be the order by? Order by will be login date. Okay, let's name it as next day, next date, or next day. Let's execute this one. So what you can see, the next day for 1 is 2, for 2 is 3, for 3 is 5. Okay, and the next is 5, so 3 is 5. For 5 it's 6. Okay, but for 6 there is no prior date, 7. Okay, in this window, because we have selected for partition, we have defined the partition for a user, so it will take this window. Okay, now let's say I need what, 3 consecutive, so next day after tomorrow also I need. So in that case, if I go with this, but here I'll do a 2. Okay, let me execute this one. Next to next date. Okay, what is the problem? We'll require this from run this query. Okay, so you can see that for user ID 1, if you start on the first, you have a tomorrow and also day after tomorrow. So 3 consecutive you have. That's why this row will come under your condition. This row will not come under your condition, right? Because it's not consecutive 3 days. And this row will what will be the difference? This row 3 5 6, this will also not come, because the difference between 1 and 3 is 2, difference between 2 and 5 is 3, difference between 3 and 6 is 3. That is how you are coming with the consecutive, right? Difference of 1 to 3, so difference of 1 to 3 is 2, that's why this is consecutive. Difference of 2 to 5 is 3, which is not consecutive, right? Till now we have understood this part, like what exactly we have to do. We will take a difference, and for 3 consecutive days, the difference between first and the third will be 2. Okay, now I'll write a difference. Okay, so I'll do login first minus last. So what I'll do first is current date, current or current row minus, I will do uh, next to next date. Okay, and I'll print the difference. Okay, and the difference between these two. So let's write this one. This is current minus 2. So this will give you the, yeah, next uh next to next, this correct. And if I do 1, okay, so it will take a difference of day 1. Okay, in short, it will skip 1 means pick the next date or the next row, and 2 means pick the next second, matlab next to next. So next date. Now I'll take a difference. So what I will do is login date. So login date, date type minus. So in Postgres, this is how you will write, but in other database query language, you can use a date difference function. So this is the login date minus your this one, which is next to next date. So I'll take this one and then as difference. So let's execute this one. Next to next, what is the problem? Okay, I don't require this one here. Let's execute. Okay, so minus, okay, got it. So I need to do, I did a present minus future, that's why it's getting a negative. So if you do a So because this is the future date, right? So you'll do, and okay, we must add date also here. So okay, now the difference, execute the code. So we'll pick all those where the difference is 2, because difference 2 means that there is 1, 2, and 3 consecutives. So I'll store this into a CTE with C with CTE as mentioned here, and then I'll write a query, select this thing, because I have to select the user ID, right? So select distinct user ID from with CTE. Okay, I've write with CTE from CTE where your diff is equals to 2. Diff is equals to 2. So you can see 1, 2, and 4. These are the user IDs where I mean, these are the people who logged in consecutively 3 times, at least 3 times. So let's start with our fourth section, which is database theory and transactions. And the first question, or you can say the 16th question, is define ACID property. This is one of the very important property, and everyone who is data engineer or like working with databases should have a understanding of ACID property. So let's go one by one. Question says that your interviewer can ask, what are the ACID properties of a database transaction? Explain each briefly. As it's a theoretical question and it's very important. So it's test your understanding on the transaction reliability. So this transaction part. So let's discuss first the atomicity part. And you have a friend A and there is a friend B, and you send, let's suppose, 10,000, okay, from A to B. So what atomicity says that, let's suppose if in the middle for some chance 10,000 is deducted from A's account and is still not credited to B's account. Okay, this is generally happens. So if you have used UPI, this is a very common error we faced. Let's suppose you made a payment to in a shop, but it didn't receive there. So what happens after 2 days or after one business day, it rolled back. This is what atomicity says. If the transaction is cut in a middle, so either it will succeed or it will roll back. Either it will commit the change, or it will roll back. There is no middle ground. If 10,000 is debited from your account, so either it will credited to the B, or the money will be returned to your account. And if it is credited to B, then yeah, it's the transaction is completed. So it's a commit phase. And this is what atomicity means. Either a complete transaction is completed, and if it fails in middle, the complete execution, whatever happened, will be rolled back. You can understand like this: a SQL query is executing, and in middle something happened. Okay, so what it will do, instead of like being in this ground, it will roll back everything what it did and go to its stable state. Okay, now I hope you have understood the atomicity part. Let's go with the consistency. Consistency says the transactions maintain data integrity. It means like uh, let's suppose it's talking about the stable states. Okay, basically the stable state. Let's suppose A is having 1,000 rupees and B is having 2,000 rupees. Okay, and their total is 3,000. Okay, now a transaction happened and A transferred 500 to B. So what will be A's value? A value will be 500 and B's value will be 2,500, and their sum will be 3,000. So this is maintained, right? The total summation is maintained. There is no fault. So this is what consistency means. This is a stable state, and this is also stable state. Okay. So this is what consistency means. Transaction maintains data integrity. Okay. And let's suppose for isolation, let's go about isolation now. So in isolation, it says that transactions are independent. Let's suppose multiple people are okay. Let's suppose there are Tatkal tickets. Okay, Tatkal ticket. There are only two tickets left, and 100 people are making the transaction. Okay, so either only two peoples will be able to make the transaction. Only two people will be able to make the transaction. It will be no in the middle, like 3 4 people get the this one, the tickets. No, it won't happen. It's an isolated. Your transaction is isolated to my transaction. Okay, so whatever you changes will make will not interfere in my changes. Coming to durability, it's basically the committed changes are permanent. It is basically, let's suppose you made the transaction, and in the middle the transaction is happening. Let's suppose transaction is happening, and in the middle something happened in the between the transaction and it failed. So as per durability, whatever was the initial state should be there. Okay, it will always be in a stable state. It won't be like, okay, some amount got deducted. Okay, committed changes are permanent. Basically, if 10,000, let's suppose 10,000, or for example, my balance is 10,000. Okay, and there is a database crash, something happened. Okay, so after that, the amount of A will still be 10,000 only. There will be no change. This is what durability means. If there is a statement, or if there is a maintenance, or if something happened, let's suppose the final amount is 10,000, whatever happened, it is permanent. It won't change unless and until there is a transaction happening. So this is what acid property means. Whenever you try to answer this question, I would highly recommend you to go with examples. So the next question is like, write a SQL transaction to update stock in a product table after a order. The rollback if the stock becomes negative. Now you have a stock. Basically it's saying that write a transaction. Okay, you have to write a transaction to update a stock. You have to update a stock, and here is the if condition. If the stock is greater than 0, or if the stock is smaller than 0, right? These are the two cases here. What's saying that? Rollback if the stock becomes negative, and if it is not negative, then commit the changes. So first things first, you have to make a transaction. So first begin the transaction, then you have to do an update. Okay, so you will write update product. This is an update statement, update product, and set stock is equals to stock minus 10. So there is a transaction of minus 10. Let's suppose initially it was 12, and you did a 12 minus 10, so it will be 2. And it's saying that if the product, and this is the where condition to update which product you want to update, and this is a if condition which checks the condition part. It says that select star from product where product ID is 1. So you selected that particular row, or the entry or the record, and you check that if the stock is negative. This means negative. Okay, if this is negative, so you are saying a rollback. So in short, let's suppose S is equals to 8 here, and 8 minus 10 is equals to minus 2. Stock will be minus 2, which is not possible. Okay, if you have 8 in your initial time, how would you able to invest 10 stocks? You won't be able to. It's like you have 100 rupees you are in your account, and you are making a transaction of 500 rupees, which is not possible, right? Because the transaction amount is less than the stored amount. Similar things is happening here. If the stock is negative, then rollback, else commit. So I hope you have understood this one, and I would like you to please understand this if exists part. This helps a lot while writing a conditional statements, rollback and commit part. So let's discuss the 18th problem, which is explain database logs. Question is, what are database logs and how do they prevent concurrency issues? The type is theoretical, and what it tests: concurrency control and locking mechanism. It's an intermediate level question. So first, let's see the sample answer and we'll discuss further with an example. Locks prevent multiple transactions from modifying the same data, simultaneously ensuring data consistency. Types includes shared and exclusive. So shared is a read logs and exclusive is a write log. So first, let's understand with an example. So as we discussed, we have two types of logs. One is shared log and other is exclusive log. So shared logs is also called read log and allows multiple transaction to read a resource at the same time. No transaction can write to the data until all read logs are released. So let's suppose you have provided there is a transaction, or let's suppose there is your bank account, okay, and your bank account is having what you can say 10,000 of rupees, and you're trying to like read the current balance. So that's a read operation. You want to read the current balance, and you and let's suppose there are also what you can say even your bank people also wants to read, or like they are trying to read the account. So there is like a read log applied which says that you can have multiple transaction for read functionality. I mean, you just can read, you can't write it. Okay, so no transaction can write to the data until all the read logs are released. So let's suppose there is a query, okay, and there are 10 transactions which is trying to fetch that details. It can be from database team, it can be from your marketing team, business team, okay, they can read the data, okay, but they can't update that one because you have applied a read log. So to write or to make a change on the database or on that particular row, you need to first remove all the read logs which is applied, and then you can make a write log and then start the update. So there is, first we already discussed the read log, now let's see the write log. So only one transaction can read and write. So let's suppose once you removed all the read logs, you will apply a write log to write something, right? And once you apply a write log, it will restrict more than one transaction, okay, so it can be read or write. So prevent, as it's mentioned here, prevents any other transaction from reading or writing until the lock is released, okay, any other transaction than this one transaction. So first this transaction will happen, and only and then the lock will be released, only then the other transaction will happen on top of it. So for example, there is true transaction. Let's say we have an account table, okay, so account ID is 101 and the balance is 5,000. Now two transactions are run concurrently. Transaction 1 begins, so we are doing an update. Transaction 1 is basically updating the table stating that balance 5,000 minus 1,000, so it will result in 4,000, right? So it's an update, so it's an write operation. So exclusive lock placed here. Exclusive locks means write lock, okay, write lock is placed here, and the transaction waits to commit. So unless in the transaction is commit phase, you know what is commit? The next stable state, right? First stable state and second stable state, so in between there is a transaction phase, right? So first the account balance is 5,000, which is stable state, then the transaction started or the update started with saying that 5,000 minus 1,000, and then the final value is 4,000, so that is the stable state. So this exclusive lock placed here, transaction waits to commit. Now transaction 2. So transaction 2 is basically a read operation. Transaction 1 is a write operation, transaction 2 is a read operation. Select balance from account where account ID is 101. So we are trying to read this balance, right? So wants to read the balance but must wait if locks not shared, right? Shared lock is this one. Shared lock means read lock. So you have to wait until the locks is like the this write lock is removed and then the read lock is there, okay. So what happen if there is no lock? So transaction 2 might read inconsistent data, example before deduction is committed, okay. Let's suppose you are removing 1,000 and someone who is wanted to know the balance, okay, from the marketing team or from the bank team. So from their end, okay, they receive, okay, account number 101 is having 5,000 but actually it is 4,000, right? So, or both may update the balance incorrectly, which is a dirty read also. This is one of a term called dirty read. Now with proper transaction, what happened? Transaction one places an exclusive lock. Exclusive lock means the right lock, okay, and transaction one is done, one transaction done. Now there are transaction 2, which is the other transaction. So transaction 2 must wait until transaction 1 is committed or rolled back. Now this ensures the serializability and data consistency. So let's discuss 19th problem, which is explain the difference between a materialized view and a regular view. When would you use one over the other? So this is a theoretical type question and the level is advanced. And basically this understands the data retrieval optimization and refresh strategies. Okay. So this is a very uh, wholesome definition to what basically or the difference between these two. So I would highly like you to guys either take a screenshot or note it down in your notebook. Now let's understand this same thing with an example. So what is a view or a regular view? Basically, a regular view is a virtual table based on a select query. So remember that it is a virtual layer in short. Okay, so you have a table. Okay, let's suppose you have a table. Okay, and view is kind of on just a virtual layer on top of this. So this is a physical table. This is a physical table, and view is on top of this. Now a viewer views the data with the view. Okay, so for this, let's understand this. So it's a for remember it's a virtual table. Okay, it's a basically and it's based on a select query. So you always have to come up with a select query for a view, defining a view. So create view active users as so right now on this one we are creating a view, and from what we are creating a view, this is what we are creating. Okay, this is the main selective. So select star from users where status is active. So this is from an actual table. Users is an actual table, and you are selecting or you are querying that user table, stating that select star from users where status is active. So what you did, you filtered all the active records from the users table, and now you are creating a view on top of this. So whenever you run select star from active user, so whenever you try to run this view, right? So whenever you try to query this view, you will ultimately query this query only, the final query. So it's kind of a wrapper. So when you run select star from the active user, it executes the select query on the user table, which is the actual physical table in the real time. Okay. So, and every time you try to query this view, the same every time it will go and it will hit the main or the physical table and query out the values. Okay. Now let's see what is a materialized view. So the materialized view stores the result set of the query physically like a table. So basically, you write something, okay, or here you just want to understand something. So let's suppose you have a table, okay. Instead of a virtual layer, you will store the query into some table, some physical table, and you will query this only, right? So it is kind of a filtered table with some conditions. So basically, a materialized view stores the result set of the query physically. So this is the physical table, like a table, right? And it improves performance for expensive queries. We will discuss this one. But the data can become stale. Stale means the static, okay, right? So and it needs refreshing. So let's go point by point. So first point, it says our here view stores the result set of the query physically like a table. So whenever you write right here, so you write this one, select product ID sum of amount from sales, and so this is creating a materialized view. You have mentioned the materialized view. So the data, let's suppose this query filtered out 1,000 records, okay, today it's filtered out 1,000 records today. So you will store these thousands record into a into a actual physical table, and that will be pointing to this view name. Okay, material monthly sales. Got it? So it will be an actual table which will be storing your view detail. Got it? Now let's go to the second statement. Second statement, it improves the performance for expensive queries. Let's suppose, because whatever we work in cloud or anywhere we work, the costing is depending upon the query you run. If you run a huge query, or let's suppose select start from a table, the users table where there is billions of data, and every time you or millions of data, and every time you write select start from users table, so it will go and always hit the query, and it will again filter it. So it will take good amount of time and the computation whatever it takes. So if you run the execution, let's suppose the query executions takes $10. So if you run in a day 10 times, so it will take $100, right? Or more than that. This is just an example. So because you are doing all the filtering and everything, you are filtering a set of data from a huge table of data. Now let's suppose what you did instead of, and you know that I need to query this view, material view every time. So you will store it in somewhere, and whenever you need, you just query from that. So it won't take much of your this one. Either it won't take much of your storage, and also storage depends upon the query data, and it won't take your performance, so it will not degrade your performance, it will not do the extra computation of that query part, right? So it improves the performance. Let's suppose you want to select the unique username. So let's suppose from order list you have 10 uniques, but 10 uniques only, so you will store that 10 unique into one materialized view, and whenever you require you will just query that material view. So it will always query the those 10 records instead of going into the users table and do a distinct on top of the complete huge table. So it will take performance, it will degrade your performance, right? So this is how it will improve your performance. Now next is, but the data can more still. Let's suppose, so today you have thousands of data in your memory, but tomorrow let's suppose someone get a new entry into the users table, but that is not stored into your material view. So that's why you need a refreshing it. You need to refresh the material view to get updated, to be updated with the main source table, right? So let's see the differences. Storage wise, the regular view, no, it's virtual. So storage wise, we are good here. But in material view, we have to deal with storage. Speed wise, this is slower because every time it compute, right? It go to the query engine, and the query engine go to the physical table and do the computation. Here we have already pre-computed, so it is faster with the performance wise. So performance of material view is good, and regular view is good with storage wise. It is as you are doing a real time, so it will be always current, so the data will be always refreshed with the source table. Here the data may be stale, unused, or refreshed, so you have to refresh it every time. Okay, lightweight, simple, and query use case is like whenever it's a very light, you don't want to run a huge query every time. In that case, go for regular views. But if you have a heavy aggregation, you're doing good amount of transformations and aggregation, everything, then running a query every time will take too much of your performance, right? Your processing unit. So it's like either you have to deal with the performance, either you have to deal with the storage. So you have to trade in which part you have to like pick. So let's suppose if you have a read extensive work where you have to do a lot of analysis, you have to do a lot of select query, you have to do a lot of reading. In that case, and the query you are trying to read will take, like a query running take 1 hour. Okay, you executed a query and it took 1 hour to give you the result. So let's suppose if you want to run it 10 times a day, what will happen? It will take 10 hours, right? So what you will do, you will store that query into some value, that the result of the query into the value, and that time whenever you require, you will do the you can use a material view at that time when performance is a challenge. But when performance is not a challenge, storage is a challenge, then go with the regular view. Hope you have understood the problem till now and the differences. Let's move to the next problem. So the next problem is cascade in future foreign key. Okay, let's understand this. What does on delete cascade means in a foreign key constraints? is a theoretical based, and it tastes the foreign key behavior or the referential integrity part. The level is intermediate. So we'll come so let's first understand what the definition is. It's a on delete cascades automatically deletes the child record. Remember the child record when the parent is deleted. Example, in order referencing orders referencing the customer tables. So deleting a customer removes the order. In short, or let's see one example. Here you have an department, right? And here is an employee. So let's suppose you deleted one department, right? And if you applied the cascade on delete cascade on this table, because if let's suppose if this is my main table, let's suppose this is my main table, right? So if this is a main table, so this will become the foreign key, right? So if I do a cascade delete on cascade, true for this one. So what will happen if my parent, so for this the main entry is belongs to here. So somehow if this is got deleted, in that case the entries which belongs to this department will also be deleted like this, because th this, right, these are the child and this is the parent from where you are taking the reference, right? This is the reference place. Now again read the on delete cascade automatically deletes child record when the parent is deleted. Example, if orders referencing customer, deleting a customer removes their order. So here it's like the employee is referencing a department. So once a department is deleted, the employees will also get deleted. So let's see our fifth part, which is scenario based in practical applications. Now this is the 21st question, which is asking for the identify the inactive users. The question says that write a SQL query to find customers from a customers table who have not placed any order in the orders table. We'll try to solve this problem with the left join and the null handling. If you have any other option or any other approach, do like post it. Now coming to the level, it's an intermediate level question, and you have to write the SQL query for this particular question. So it's on practical based. Now let's go to our console and write the query. Now let's go through customer and orders table one by one. So we'll go with the customer table. So in the customer table, you can see you have like 4 customers, which are having customer ID 1, 2, 3, and 4: Vaibhav, Akriti, Ravi, and Simran. Now for these customers, let's copy this data. Okay, so this is your customers, and now see the orders ID, orders table, and now this is your order table. Okay, now as you can see that for on the orders table, only the customers having customer ID 1, 1, and 2 place the order. Rest 3 and 4 haven't placed any order. So with our question, these two will be the customers who haven't placed any order. Okay, so what we'll do, we'll write a query select. Okay, and what we will select, select star. So we'll select this one, customer ID, customer ID. Let's do one thing. Let's go from what we'll do, we'll go with the customers table as left join. Let's go one by one. See, left join orders. Oh, and we'll do an on operator in which c dot customer ID ID is equals to o dot customer ID, and let's print c dot star from o dot star. Okay, now so you can see that the customer ID, these are the customer ID and these are their names and the order ID. So what you can observe here is order IDs are null for Simran and Ravi. This is what we are trying to find. So what we did is basically we did a left join on the customers table, which means that we did the priority given to the left table. So here this was the left table, okay, and in this particular left table, what we did, we joined it with the order ID, and whatever place where the order ID is null is shown here. Like these two have the no order ID, okay. So in this case, as per the questions, this will be your orders, or this will be your customers who haven't placed any order. So we'll write another query or a filter condition where to filter out these, what we will do is the order ID is null, where order ID is null. So where o dot order ID is equal, is null. Let's see. So these two we get, and we have to just print the name, customer name. So we'll go with the customer name, which is let's see the column name, name, that's all. Okay. So if we execute this, and here it is, Simran and Ravi are the two people who have like zero order ID. So let's solve a second problem, which is employees earning more than their manager. So this question have been asked in majority of the interview questions, and let's solve this problem. So the question says that write a SQL query to find employees who earn more than their managers. And it's a coding type. And what you will learn is you will learn the self-join concept here. It's an advanced level. So let's try to solve this problem. To understand this, let's go through the data first. Okay, so now this is the data. It have column ID, name, salary, and manager ID, and you have to find those employees who have a salary more than their manager. So let's see one example. What I'm trying to say is, let's take row number one, where the employee name is Joey, and Joey's salary is 70,000, 17. Okay, it's 70,000. Okay, so Joey's salary is 70,000, and Joey reports to manager, uh, his manager, and the ID is 3. So employee with ID 1, Joey, reports to employee ID 3, and employee ID 3 is Sam. So Joey reports to Sam, and salary of Joey is greater than his manager because his manager's salary is 60,000. So Joey will be one of the candidate for the question, for the solution. Like Joey is the person whose salary is greater than their manager, and from his this row I can identify Joey's manager is someone whose employee ID is 3, and employee ID 3 belongs to Sam, and Sam's salary is 60,000. Looking to this data and looking to the like what I'm trying to achieve, it will be easy to go with the self join. Why? Because I am doing the comparison between the rows in the same table. Okay, that is why I will do the go for the self join. So whenever you think, okay, how to you figure out that it will gonna help, self join will gonna help, is like whenever you see that one of the rows is getting compared with another row in the same table, in that case go with the self join. Now let's write the SQL, or let's see the self join first. So let's select star from. So I'll go with the employee, and how self join works is employee, then go with aliasing E1, and join employee E2. So it will be going to join with the same table, but we will put aliasing different alias, because if you go with the same, it will say, it will throw an ambiguous error. Okay. Now employee 1 and employee 2. Now let's go with the joining condition, because whenever you write a join, you write their condition. Okay. Now if I say even even ID should equals to manager's ID, or let me go to the data and then again explain what I'm trying to say. So how it will be feasible for me to get the data? So what I require is, here is 3. Joey's salary is already given here. Okay. What I want detail of manager ID 3. Okay. I want this data to be present here so that I can do the comparison. Correct? if somehow I am able to make, or I'm able to store Sam's data at row number 1 where Sam is present, in that case it will be easy for me to do the comparison. In that case, what common you find in these two rows is that uh, manager ID from this is equals to the ID of the another. So treat this as like two tables, okay, E1 and E2. So if I take E1's manager ID should equals to E2's ID, in that case this value can be placed here. So let me show you. If I go with E1 E1 dot manager ID is equals to E2 dot ID. Let's execute this one. So now we can see that, see, initially we have this data, and here I placed the data belongs to manager ID 3, and now in the single row 1, I have this both data. I am able to compare the employees data with their managers data. So here is the employee data 70,000, and here is managers data 60,000. So I can do the comparison now, and I'll go with another filter condition like salary of the ID or salary of the employee should be written there, salary of their manager. So in this case 60,000. So this will come. Let's go with the Henry. Henry's salary is 80,000, his manager's salary is 90,000. So no, it will not come. Alice 75,000, Sam 60,000. Yes, Alice will come. Bob 95,000, and Max 90,000. So Bob will also come. Carol will not come. Dave will come. Eve will not come. Frank will come. So write the condition where E1 E1 is the employee, belongs to employee. Okay, so E1 dot salary is greater than E2 dot salary. So let's execute this one. And now we found Joey, Alice, Bob, Dave, and Frank. Now I just want the I, details belongings to the employee. So I'll go with E1 dot name. I think name is there. Name and ID. So I need name and ID. So E1 dot ID comma name. If I run this query, so I get this. These are the people whose salary is greater than their manager. So let's solve the next problem, which is update employees bonuses. This question says that write a SQL query to increase the salary by 5% for employees in an employees table who have worked more than 5 years based on higher rate. And this is a practical based question, so you have to write SQL for this, and it's an intermediate level question. And what is the thing you will learn is like how to update, okay, update and date functionalities. For different databases, query language will be different. For MySQL, for PSQL, so it will be a slightly changed, but the concept will be the same. Okay, so let's see our data and try to solve this problem. This is our data. What you can observe here is this table consists of ID, name, salary, and hire date. So Alice was hired on 2015, 15th of March. Same for others. Okay, and what you have to do, those employee whose what like employment time or age in the company is greater than 5 years, for those we have to give an increment of what like 5%. Okay, so in that case, let's see the age first, like which what is the time employee has spent in this company as per their hire date. So let's go through the query. This query basically, the first four columns are common only. This ID, name, salary, and the hire date. The part of discussion will be this one, date part. Here in this one, like date part basically provides the difference, okay, difference with respect to year, month, day, and hour. Right now, I concerned with year, so I'll go with year. If you concern with month, you can go with month. Now the next clause or the next argument is age. So age will give you the difference with respect to the current date and the higher date. You can update this one. Okay, these two are like day 1 and date 2. Date 1 and date 2. So here the date 1 is my current date, okay, and date 2 or is the hire date, okay, and whatever difference will come, that will be converted into years format, okay, number of years, and in this we will get an idea of which employee have spent what amount of time in the company. So let's execute this one. Now you can see that Alice is been in the company from 10 years, Bob is 6 years, Carol is 10 years, Dave is 5 years, Eve is 9 years, and Frank is 5 years, Grace is 12 years. So what we have to do? Those employees who have spent more than 5 years, in that case, Alice will be there, Bob will be there, Carol will be there, but Dave will be not there. Dave is just 5 years, not more than 5 years. Okay. Eve is 9 year, we can go with that, not with the Frank, with the Grace we can go. So let's write the query. Now, what exactly I need is I need to update. So I'll go with an update, update, update what? So I'll update this table, employees table, update employee table, and set. Set is what we want to update. So I want to update a salary. So salary is equals to salary times 1.05. Okay, 5%. 5% of what? Now you have to pick the rows where the condition, where date part, okay, this is greater than 5, than 5. Okay, so let's see the previous data first. Copy this one. So initially this was the data. Now let's execute the update query because this will update the same table. Okay, this is executed. Now let's run again the query. Okay, and copy the data. So these two are the non-incremented, Dave and Frank, because Dave and Frank belongs to those category where the where condition is failing. Basically, it's not more than 5 years; it's just 5 years. So Alice, Bob, Carol, Eve. Eve's salary is 90,000 early. Now it is 90,000 for 94,500. So it got updated. So this is how you can use the update statement. So the next problem is delete duplicates. The question is that you have to write a SQL query to delete duplicate emails. And it's a coding type, the level is intermediate, and what it will test the delete clause, group by, case insensitive, string handling, subquery or window function, and data cleanups. Now, so you have given a table, okay, and in this table you will have multiple email IDs which are duplicates, and your task is to delete the duplicates and have the unique ones with you. Okay, so this is our table. As you can observe that uh, email ID a@b.com and a@ so ID 1, 3 and 7 and 12 are same. So if you see that a@b.com, so these are the four occurrences, okay, and it's case insensitive. So now see the analysis on the table, and you will find that a@b.com is occurred 4 times, and I need only one, so I have to delete the 3 occurrence. For c@d.com, it's 2 occurrence, so I delete 1. For X same, and for John, Dio, Mary, so these are the occurrences, and I have to delete the duplicated one. Now we have to delete the unique, delete the duplicate. So we have to find what are the duplicates. For that, we will use a row number to see what are the other occurrences. And we have to do a partition on top of the email. Okay, lowering this one and order by ID. So let's first execute this one. So now what you can see is like in this window, in the first this window belongs to a@b.com, and in this one these are all the duplicates and the unique in the same window. Okay, and you have this row number for each 1, 2, 3 and 4. So this belongs to one window. Now C and D, if you see this one, it's this window consists of only 2 records, C@D. For John Doe, this consists of only 2 records. Mary will consist of 2 records. Now this is unique because it's have only one, and there is no, so this window consists of only one record. Now this window consists of one record, but x at the rate y consists of two records. So we have to delete those records who is having more than one, okay, more than one row number. Row number belongs to more than one. So in this case, let's go with the first window. I have to delete these, okay, and I have to stick with anyone. So what I'm doing is I'm going with the very first occurrence and I'm sticking with that, taking this as a unique, and the rest I'm going to delete. Same here, I will delete this row, and this I'll delete this row, and this I'll delete this row, and here I'll delete this row. So basically, I'm going to keep all the records wherever the row number belongs to 1, and rest whatever is not belongs to, which is greater than 1, I will delete that one. So in this case, I'll delete. So I'll say delete from person, where where row number, or this one. Okay, so I'll first store this into one of the CT. So ranked with ranked ranked CTE. Okay, now let's print this one. Okay, so we'll see the first the CT. Cool. Now we'll filter out this one. Uh, so what we will do is we will figure out all the we'll figure out all this one. Okay, ID. So we'll delete this ID. So I'll do this one, where row number is, or I'll do where row number is greater than 1. Okay, let me execute this one. Okay, what is the problem here? From this, where row number, okay, got it. But I have to use qualify there, but so if I execute this one, what is the problem here I'm getting? Okay, got it. Don't need this one, the row number. RN. Okay, so we got this one. Okay, and I have to delete all these are the records which I have to delete. So I'll take all the IDs. Okay, so in this case, select all the ID, right? These are the ID I have to delete. So delete from person, where ID in ID in this one. Okay, so what I am saying that delete all the rows which comes under this city. Okay, okay, delete the 7 records. Now if I go and select the person record, so we have all the uniques with us. Now coming to the next and the last problem, which is return the number of rows resulting from inner join, left join, right join, and full outer join. So I have discussed the same question in one of my video. I'll provide the link in the I button. Okay, there I have provided a detailed description on each of the rows, okay, and each of the joins. So I will request you to go and watch that video. I'll provide the link in the description and also in the I button. So now this is the last video, and yeah, we are done with our 25 interview questions. I think this video got a little long, but yeah, I try to cover as much as possible. Now, if you have any problem or doubts, do let me know in the comment section. If you like this video, give a thumbs up and subscribe for more upcoming videos. Thank you. Happy coding, everyone.